Okay, my friends, Roger once again, and today, what I'm going to explain to you today is about hot and cold. What creates heat and what creates cold. And I'm going to tell you right now, it's not understood. And this is so simple that it's almost impossible to get anybody to understand it. Now, pressure is heat, really, but pressure itself is not the heat. It's a little tricky. It's an increase in pressure that produces heat. And again, they still don't understand this fully, but they understand that an increase in pressure produces heat. Why? That's the key. Okay, I can tell you exactly why heat comes and goes, and it's strictly extra electrons that are floating through every single thing there is. Every single thing there is has as extra electrons until you hit absolute zero. Absolute zero means there's not one single extra electron. Absolutely zero extra electrons. And then you say, well, how would that make it so conductive? Do you need electrons to conduct? No, they will suck electrons through there because normally there will be a ton of extra electrons in there. We have literally removed them to bring it down to that cold temperature. They want to go back in there. That's what the superconductivity is. It's not that it just will flow through there forever unless you keep it that cold. That's the key. You have to keep it that cold. Then it wants electrons. It sucks them in. That's superconductivity. Now we're going to understand how push and shove creates these energy changes, and it's related to the range of distance that the particle itself controls. And we're going to look at hydrogen 21 centimeter line right now, and that'll give you a little bit of an understanding. And we're going to go into this deep, and I'm going to show you exactly how this happens in exactly pictures of these particular things doing what they're doing. Because Rod Warren, with his Venturi, has created a situation where we can literally see electrons, and we can literally see the strong force disassociate from the weak force. That's the bosons and the fermions. It's outstanding, it's over the top, it's spectacular, but it's true. And I know that you guys are just people that don't have, you're not working in the academic society. No, we're not. They won't look at this because it overrides their information. And it overrides it 100%. And so I want them to discuss it with me. If they don't discuss it, as far as I'm concerned, we win. Okay, as most people know, I do the light research with Rod Warren, and we're using his Venturi to actually see the particles. Now, this is Rupert Sheldrake, by the way, and this is a talk he did. You should watch this. Dynamic Patterns in Water as Analogous Models. Now, models of what? Of the nucleus of atoms. And you say, ooh, that's interesting. And I say, yes, it is. Now, what are we looking at? You see that? That's a tortoise shell. It's almost the same as these kind of patterns. And the more complex the pattern, the heavier the molecule. Let's look at this in actual creating these patterns, because they're made by vibration of magnetic particles. I'm going to show you, and you'll see it very simple. If you got any 8-year-old, 10-year-olds around, they'll fully understand this. Okay, I've shown this many times, but electron flood theory is my theory, and it says that every particle that exists is an electron. They build together to make photons, and then they build together to make atoms, and then they build together to make molecules, and then they build together to make chunks of things, rocks and chairs and everything else. Now, and they have a positive and a negative end. And the nucleus, the center core, which has always been thought to be positive only, with some neutrons in there which are neutral, is not anything like that. It is just a compilation of a bazillion electrons. And even the smallest particles there are. Helium is a pretty small atom. It only has what they thought was 2 protons and 2 neutrons. Well, it really has 7,350 electrons in the core. And then 2 more electrons out here that want to get in, but the core says, no, we're already saturated at this exact frequency. And I'm going to show you these frequencies, because these frequencies correspond to these patterns. It becomes very simple when you understand that the nucleus of every atom that exists, of everything there is electrons. There is nothing but electrons. And as you start to atom, these nucleuses will occur. Then the nucleus will dictate where the external atoms, which we call the orbital atoms, are. They will be in pockets. Like you see that 2 little thing going there, and 2 little thing going there, and 2. There'll be an electron here, electron here, electron here, one over here, one over here. And that one will push another one out. There'll be one over here, one over here, and one over here. They will all push each other away from each other, just like the bar magnets do. And this is a good representation of it. But these are all little magnets on their own. And the way light works, I have determined, is that depending upon the distance that this electron is from the mass of electrons, which is the nucleus, depends on how fast it will exit, because it's going to have to be pulled like hell out of here, because it's real close here, and you're going to have blue light. If it's way out here, you could just bang it away and it'll just go swishing away in the red range. And in between, there's all kinds of different distances, which will be hues of these colors, because the color is strictly the impact of the particle. It's the frequency of the particle, the distance. If they're going, you got blue. Long distance, you got red. Okay, I know you're going to say, well, what's the 21 centimeter line? Virtually nobody knows about it, even the physicists. And I'm not bragging, but I want you to know, I've been doing this my whole life. I understand this stuff intimately. I have no issues discussing this with anyone about every bit of the interactions of molecules and electrons and all the... I've done this my whole life. I understand this as well as anyone, and if anybody wants to speak to me about it, that is exactly what I want. Now, the 21 centimeter line is nothing more than this electron, okay, which they're talking about the hydrogen nucleus, but every electron has the same capability. I don't know the distance it controls, whether it's 21 centimeters or not, but the hydrogen at 21 centimeters away from the center, it flips the spin of the electrons that it encounters. That's a hell of a long distance away from a particle that there's nobody can see. You know, Rod has shown them in his experiments with the light, Venturi, but virtually nobody else has ever seen this level of detail. Now, before we get started, I want to point out that this is the Large Hadron Collider at CERN, and they're taking gigantic particles, thousands, you know, like these 7,000 sized particles, smashing them together and digging through the debris. And you can see the fields that they create, which are always going to be the same sort of fields because they're circular Higgs fields. Yes, however, we are using light. So light is the smallest particle there is, and then we create the Higgs fields. They are creating just chunks of matter, digging through it for years and years and years, trying to find the smallest bits they can find. And then they keep finding more and more things, and they're just confused because they think the nucleus is separate from everything else. The nucleus is nothing more than a ton of electrons. All right, let's look at that. Okay, now don't forget, we're working with light. It's a red laser. It's light. Light is light, and it is photons. And photons are comprised of back-to-back electrons. And I'm going to show you this in vivid color. and they come in a box like this. That's what a photon looks like. And depending upon the crystal that it's being emitted from, the vibration of that crystal will either be extremely fast, and it'll be a blue particle, because it's got power and really smashes into things, or it could be a little less or a little less or a little less. And in the case we have, we're using one of the smallest, longest wavelengths, which is the red. So what are we seeing here? We're seeing this, well, let's go back to this again. That's the red laser. This is going to be the waves that I will show you. They're not really waves, they're particles, and you will see that as they accelerate. Then we'll see them compress at the venturi, which is two drums, which really creates an airplane wing that just does nothing more than force everything to expand, or to accelerate. And that's when you get all the Cherenkov radiation happening here, and then you get these particles spinning out. That's called a venturi. Photons are the little box you'll see in a second. Electrons are a half of what you would normally see as a photon. And then when they concuss, you have one part creates extremely brilliant white fermion radiation, which is the strong force, and then the black part just walks away, and that's the weak force, and it's called a boson. A concussion separates these charges through that venturi, and I again will show you that uno momento. This is the pulse red laser. Pip, 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 pip. All of these little glowing things here are free electrons, and this is what they don't get. Every single thing there is has free electrons. They're in there and they're just stuck inside, but they're not really parts of other molecules. They are free floating, and that's how things heat up and they cool down. Those are the things that come and go. I'm going to show you, and they're nothing more than little bar magnets. And if the ones on the outside are colder, they will leave and go to those. Which means there's less of them. When it's colder, there's less of them. That's all it is. So there's more in here. They will flow out to where they equal each other, and they will become equilibrium. Nobody's pushing, nobody's shoving. In this case, we're shoving these red electrons like hell through here. Boop, 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 boop. So everybody out here has to get out of the way, because that particle, that wave that we are seeing here, is not a wave. It's a particle. And here's that particle. Right there. It's coming out, boom. And in front of it, everybody's got to get out of the way. So all of these particles, which are the free floating electrons, primarily attached to water molecules, they start to glow because they are concussed. Then the wave, which is not a wave, it's a particle, accelerates. We can see it accelerate, and now the particle nature shows, because the fermion portion of the electron, which these are electrons, they're light, but they're electrons in a box, a photon. The fermion excitable portion starts to glow. Then when it concusses down here at the venturi and has to accelerate, it pushes the black parts away, which are the positive portion of the electron. Alright, so I hope that didn't confuse you, but I'm going to go in a little deeper. Alright, this shows that the light is actually spinning to the right, means it drifts to the left. It's expanded here, concussed here. That means it's slowing down. So the light is expanded, spinning to the right, drifting to the left, slowing down. Now, this over here is the actual particles of light. And I said they were particles. There they are. They are those photons, back-to-back electrons. Now, when they concuss at the venturi, they literally explode, and the white part leaves in explosiveness and leaves the little black balls. We're going to see that in a second. This is a particle that's not understood yet. It came through the venturi with all the rest of the red light, so it started with the rest of the red light, and for some reason, I believe it's spinning backwards when it came through, and it's like gathering its field instead of throwing it out. And then it concussed with one of these normal Higgs fields, and then it did this. So let's see the actual boson, and then we're going to talk about how heat moves and how you can create absolute zero by removing, well, you can't really absolutely create absolute zero. It's just, well, in my mind, it's impossible. But I suppose there's a way to do it. I just, they're getting close. Anyway, we'll go into that deeper. You remember that the red light was coming through here in a ball like this. The particle is just in the center of it. But as soon as it starts to hit here, everybody's got to force their way through here. That's where all the white ones, they do not want to be around each other. They force each other away. That's your negative push. That's what we always consider was the electron. It is. It's the electron, but it's the only half of the electron has any power, and it's the white half. The black part is what they call a carrier boson. It has like 1 electron volt, just enough to carry the white part until the white part explodes, and the white part is like a firecracker. It just explodes. And depending upon how hard it hits something, how much explosiveness there is. Now, this brings up an extremely interesting possibility. As far as I'm concerned, at this point right now, there is no atomic structure to this particle whatsoever. There's nothing. This is completely negativeness, and the little black ones are the positiveness. Now, when they come back together, it appears they come back together as light again. Now, is there a way that we could inject a frequency in here somehow, and at this point make them sort of rearrange themselves into whatever we wanted? Why not? You can, well, let's look at it. All right, I'm going to show you how these magnetic particles stabilize themselves at certain frequencies, and all that means is they're going to shake like crazy until this one finds its way of opposing that one, and this one here finds its way of sitting in the middle of that one, and this one finds its way of that, and then all of a sudden they lock in. That's called resonance. But in between that, they're just going crazy. Nikola Tesla understood this 100%. When you think about energy, think in terms of frequency and vibration. How fast are these things shaking back and forth? Because all vibration is plus minus, plus minus, plus minus, plus minus. That's all it is. That's all vibration is. You hit something, it goes plus minus, plus minus, plus minus. If you turn the frequency up, it's plus minus, plus minus, plus minus, plus minus, plus minus. Case closed. That's all vibration is. Now, let's see what they do. And I'm going to explain to you on the salt table. This is a frequency table. And again, plus minus, plus minus, plus minus. Now, this is where it's important to understand the periodic table. You got salt, NaCl. They're going to be putting salt on here. And virtually every molecule has a dipole center of positive and negativeness. However, salt has extreme positive and negativeness because that's what dictates the sides of the periodic table. This has a ton of extra electrons. This has no extra electrons to speak of. So they want to click together as a bar magnet, and that's what they're going to put on here. So don't forget, this is just magnetism, plus minus, plus minus, plus minus, shaken. That's all this is. And as they turn the frequency up, it goes faster. The plus minuses go faster and faster. And as they do, they shake the salt up and down, and as it shakes up and down, it pushes each other around until they find a pattern where they will lock in and be stable. And that pattern will be an exact certain number of electrons. And the certain number of electrons at helium, when it is a stable molecule, will be, a stable element, will be 7,350 electrons in the core. That's 2 protons, 2 neutrons, the equivalent of it, because there is no protons and neutrons. Just forget them. And then it will have 2 more electrons in the outer orbital that they're trying to get in, but this has enough negativeness in it that the negativeness will oppose these negatives trying to get into the positiveness of the core. You end up with 7,352 electrons make helium. All right, now watch what happens as the salt, which is nothing more but bar magnets, gets pushed up and down by nothing more than a positive negative frequency. Here goes. They're going to start low, and which will be helium. I mean, will be hydrogen, really. Hydrogen and helium only have an s orbital. And you can see. Now, here's your salt. Now, think about this. Remember this. Every one of those is an electron. Every one is an electron. So, at a certain frequency. Right now, they're just they're not never going to stay like that, because if they're like that, they will just be moving in and out of substances, because there are a ton of extra electrons, yes. But once they form a substance, a molecule, an element, then they are fairly well locked in there until you do something special with electricity or extreme heat. Then you change their molecular structure. But when they are basically sitting around, they're all, yeah, and they're not, a little bit warmer, a little cooler, that's okay. But once you really rock them and heat them up so much, they'll actually combust, and then all of the molecules would change and all that stuff. But let's think about, remember, every one of those is an electron flood theory. So here goes. These are the smallest molecules or smallest atoms there is. So they're going to vibrate. This tone generates. It's not a tone, it's a plus and minus. And as they go up through the distances, see this wave? Now watch. Watch this happen. Bang, it locked in. Now, the lowest, smallest molecules there are only have an S, they only have an S orbitals, which means 2 electrons maximum, which is like this in the helium. All right, that's the center. Now, after that, you go into the rule of 8. I'm just going to come out here and show him, because then I'm going to show him Sheldrake stuff. He's got some fabulous stuff. And what will happen is, in between all of these different frequencies, you have chaos. And that's called nuclear decay. The nucleus is literally decayed because it's not in resonance stability. Now, what I have discovered, and I'm pretty damn sure this is true, is when biological processes happen and enzymes come in, they actually work on the nucleuses. And they actually construct molecules inside your body to satisfy the needs of your body. And if you don't have the enzymes, they cannot break the molecules down. That's chronic illness. And the enzymes are only there because of bacteria, and the bacteria is in there because you have not killed it with antibiotics. So take probiotics. Okay, let's go on from here. Okay, this is Rupert Sheldrake's stuff again, and he's using somebody else's stuff. But anyway, these are all the different hertz, and these are the different patterns they make. And hertz is nothing more than pressure of each electron pushing against each other one until they achieve this stability. And again, nothing but electrons makes up everything there is. Now, I'm pretty sure I get lost in these things, but I'm pretty sure I showed you the vibrating salt patterns and how that is achieved. This is inside of water. This is absolutely unbelievable, because the other one is at 2 dimensions. There's not much you can do about that. This is more or less 3 dimensions because water has a rounded surface to it. Watch and listen to this. Here goes.
And do repeatable experiments. This is shows you the kind of pattern you get.
Now, if you ever look around on the internet, you're going to see these crazy looking balls that are just fabulous looking patterns, and they have no idea what they are. And they're made out of stone or whatever. I don't know what they are. Now, they look damn near exactly like this. And what you see, these rows of dots and so forth, that's the stuff that Rod's doing with his light research. And I just got some stuff from him this, I guess it was yesterday. Fabulous. We'll look into that in a bit. But this is, as he turns up the frequency, they will get more and more and more complex. And what does that mean? If this is the nucleus, what you will end up with, there will be wells, like right there. It might want to have an electron. And it might want to have an electron right in one of these spots. You see that? And what will happen is they'll find places where they're trying to get in, but there's just enough magnetism already in there that says, no, just stay away. And the negatives will always be on the outside, because positives don't mind touching each other. And every one of these balls is a positive and a negative. So the negatives will always end up facing outwards. So the new ones coming in, the negative will try to get to the positives that are in here, but these negatives will say, no, we're negative on the surface, buddy, you got to stay away. We got just the right number of them to be perfectly comfortable here. So you can stay right out here. So one will stay out here, and one will stay over here. All right, and then there'll be some over here and here and here and here and here, and it'll be, say there's what we call 20 different particles, which they normally call them protons. What it means is there's going to be enough wells and so forth out here to hold 20 electrons. But in between this, and I'm starting to think now that there's more than just a single electron out here. There's a lot to think about now. But in between this shaken and being perfectly stable, there's going to be what they call isotopes, which are semi-stable. They're pretty stable, some of them, and then some of them are just last instantaneously and they go away because another electron is going to come in or get pushed out. I hope that is understandable, but let's watch how complicated these patterns can become and how exquisite this is, this research. And all he's doing is taking up another vibrational plate underneath a water molecules and going bzzz, and shaking them faster and faster and faster. Look at this. To me, those are all electrons.
You see, that was a threefold pattern with standing waves that oscillate backwards and forwards.
Now, the reason they oscillate backwards and forwards is they're pushing and shoving. Every ball pushes against another ball. So it's boom, 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 boom. That's it. Because that ball's got to push against another ball this way. This ball's got to push against another one. That's called vibration. It's like those things where they drop the ball and go bang, 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 bang. Well, it's the same thing here, only everybody's touching it, so it's going just like this. Squish, 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 squish. That's all vibration is. And here it is. And in my world, every one of these dots is the fermion portion of an electron, trying to push this other guy away from him. Same thing here, push me away, push you away, and they all push away in a magnificently exquisite pattern.
So it gives you a six-fold pattern altogether.
These are ones on top of each other. These are ones going this way, this way.
This is another one. This is an eightfold pattern.
All right, once you get into these extreme patterns, you see, and that's all they are, is light particles. They're the compression particle. Let's call it that way. And this outside surface is going to have a bazillion of electrons around the outside. You know, there's a lot more thinking to do. You know, as they came up with these different particle theories that said there's 16 protons in there, and there's got to be 16 electrons out here. Now everything is in extreme question. Look at that.
And by vibrating at different frequencies, you get a series of patterns, six-fold, eight-fold, ten-fold, 12-fold. You
see these patterns in church windows and everything. I mean, and you see them in, like, he's going to show some stuff that has this. It's absolutely mind-blowing. Now, they did every one. They did all of the patterns, you see. And I understand these now, because these are nothing more than exactly like the particles on the periodic chart. And in the center, you have the transition molecules, which they can take on or lose electrons either way. That gets a little deep. But now this, I'm going to show you something. Well, let me just play it from here and see what he says.
And then you get into no pattern again. It's a bit like old-fashioned radios, where you tune the radio set and you get a station, and then there's a kind of noise in between, and then you get the next station.
Exactly. What it is that the nucleus is capable of having so many electrons surrounding it. If there's just one of those, well, you're way down this end. As you add more and more, you're tuning it up until it gets to so many that it has to add another layer, and then you come down to here. And the same thing, throw more, and it's got to come down to here. That's all it is. Now, so here it goes.
So you come in and out of these resonant frequencies,
As
and
you go,
they show an
as you go up through the layers of the distances outward from the nucleus, because that's how they they'll fill up a layer, and then those ones will push the new ones in up another layer away, and that's how it creates what we consider the orbitals.
order as you go up from the bottom here: 6, 8, 4, 10, 6, 12, 8. It doesn't seem to have any logical sequence. But when you plot them on a graph, you see a very distinct series of patterns. This is increasing frequency here from 50 to 200 hertz.
Now, I want to show you something that I just got from Rod. I think it was yesterday. Remember these patterns like this. All right, now he's going to show a little more, and then I'm going to show you Rod's stuff.
And this is the foldness of the pattern with 3 replicates.
See, this is a frequency.
6, 8, 10, 12. 14's missing, 16, 18, 20. Then it all starts over again, 6, 8, 10, 12, and then again. So you see we have these harmonic frequencies.
Now, why are these harmonic frequencies? I say they are because these are the distances of the orbitals that the electrons are bumping into. That's all it is. The further out they get, you get another layer. You get this, you get this, you get this. And he's going to show it again in another way here.
The only way of modeling these mathematically seems to be using Bessel functions, which are really those like vibrating drum membranes. So there's an order in all this, which is what you'd expect.
There is an order. There we go.
When we look at the more detailed patterns, we find that these are like basins of attraction. This is frequency.
All right, there's no reason to let him discuss this. It gets a little confusing, but you can see these orders of magnitude. This one's way down here, and this one's next up, and then this is next up. But they follow the same sort of patterns, and that's as they fill up the layers of the electrons in their orbitals, then they jump to another layer. Now, let me show you what Rod just sent me. Okay, just a couple quick things. This is light spinning. That's what light does, it spins. It's a particle. It spins just like this. That's the particle. It spins like this through the venturi. And what does that mean? It's like a drill bit. You see it? It's just like a drill bit. It comes over and it dives down and comes out the other side. Now, so if it's over here, it's going to do this. If it's over here, it's going to do this. If it comes over this way, it goes under. If it's here, it goes over. All right? Now, and I can see him actually coming around and swinging back and coming around and swinging back this way. So they'll come around and swing way back this way, or they'll come over the top and swing way back that way. And they make swirls. Well, I mean, you've seen a bazillion different swirls. Now, there's a little extra thing I want to show you, which I actually just got yesterday from Rod. Now this one's kind of a mind blower too, brother. I'm seeing the light hitting this way, all the way around itself. How did you do that? I'd like to know where the venturi is here. It looks like... And are you supplementing any light coming in any other direction? And a couple other things I'd love to see you do is to come out with the normal one you normally do and then shoot something to the side, lasers to the side, smashing into it. It's that type of thing. That would be very cool. Okay, this is the one that shows how easily you can see that it's spinning. Some are spinning this way and some are spinning coming back off this way. See it? See them crossing paths here, back and forth. They wouldn't do that if they were all straight line particles. And waves don't have this characteristic. That's not the characteristic of a wave. These are particles. I've shown them in a zillion different ways. Anyway, Rod, see what you can do, brother. Good job as always, Don, my friend. Alright, I have found virtually no better way to explain electron flood theory than Latham's crazy machines. These are tractor beam magnets. And what does that mean? That means that's the nucleus. And what does that mean? That means there's a positiveness and then there's a negativeness around it. And that's how electrons will set up. They will always set up with the most positiveness towards the center and the most negativeness as far away from each other as they can get. Therefore, your surrounding rind of these nucleuses will always be primarily negative. That means that the new electrons that want to come in to get to the positiveness will be held at bay by the negativeness of the shell and kept away. And it'll be an exact distance, because this is going to create an exact amount of push and this has an exact amount of pull. Between the two, you get a quantum state. Now, this is the core, positive. These are the negatives that surround it. And that's the way he built this core. Now, watch what happens now. Another electron is going to be out here trying to get in to get to their core, which is the positive. Electrons want to get to the positive part. And it will say, no, you're going to have to stay away. Okay, now watch. Boom. All right, so isn't that cool? Now, that is exactly the quantum state. It stays there forever unless somebody comes in and bangs it with heat. And it stays between wherever the electrons are in that pattern. We showed the patterns. All those, they're going to lock. Boom, and it's locked. And then there's going to be a one here and one over here and one over here and one over here and one over, and there'll be electron cuddled up into these little pockets, just like this is here. You see? No. He's moving it around. That's just like a rock rolling down the street and it's doing nothing, no big deal. But once you heat it up, it starts shaking like crazy. And that's when you, like now he's going to start creating heat. You see it bouncing back and forth? As it bounces back and forth, that's heat. That's creating heat, friction. And then eventually it goes flying off of there and it's what we would call light. Now, and then, see it? Boom, boom, there it goes. It got hit so hard that it had to send light off. Now, before that, it's just heat, and before that, it's just vibrations, like sound. That's all it is. It goes up from, like, just barely tapping to light. Now, the more complex the core becomes, the more complex the orbitals become. That just means you're moving up the periodic chart. That's all. And on this side of the periodic chart, there's what they call a valence shell. What is a valence shell? That means it's the last shell outside here. Because some of them have one here, some of them have another one, a second one, another third one, a fourth one, whatever they have. So what it is this side means they only have like a very small number on the valence shell, because it can have up to 8, and this one has like 1. Now, if it has 8 on the outside, which is your gases here, your noble gases, they can't accept any more at all. But the ones down here that only have 1, they can take another one, another one, another one, so he can keep adding them like that. They're very reactive. This is not reactive at all. Helium, neon, all these different gases. Now, it gets a little confusing, but I don't think it's that confusing. Now watch what he's doing here. That's how these electrons are going to sit in their orbitals. All right. They're out in their orbitals. Here we go. And you see them? Now he's taking one up above, and it controls, it also affects the ones that are in their orbitals. You see it? Three-dimensional is totally different than a two-dimension flat salt vibration experiment. It has to be dealt with here and here and here and over here and over here and all the way around. You see, now they're building more and more. This is not really reality what he's showing here, but it's a pretty good representation in the world that we live in. You see it? And then he goes into copper. Now, once you get into copper, you got a different situation, because copper itself, copper, it's as an element, is just flooded with electrons, flooded with extra electrons. It's like a soup of electrons, that all around it. That's why they use it to conduct electricity, because all those extra electrons can move. And they're extra electrons. They can just go flying down through the wires. That's why they use copper. Okay, the whole story here was to show you that the basis that everything is thought of now is wrong, because everything is based on a universe that exists of only protons, electrons, and neutrons, and that is wrong. What the universe consists of is electrons, and electrons are those dipoles that I showed. Now, heat and cold is nothing more than having extra electrons. It's nothing more than having particles like this and having extra electrons just floating around, drifting around through the material or the gas. And when it gets cold, those electrons come out of there. So it's cold. It doesn't have, they're not bumping into each other. When it gets hot, you're forcing electrons in. And that's all you're doing when you heat up water and run electricity through a wire and it gets warmed up. It's because the electrons are pushing other electrons. That's all it is. And if you can suck out every single extra electron that's in here, that's absolute zero. No extra electrons whatsoever, and that is virtually impossible. Now they've done it in outer space by putting, because outer space there's nothing forcing the electrons to push together. They're just sort of floating around out there, and you can pull all the extra electrons out, but then you have to keep them in a vacuum chamber. And they've been doing this experiment, I guess, on the space station for a while now, where they have a vacuum chamber, and then they get these electrons down to where they're almost absolute zero, and then they let them expand in there, which gives them an additional reduction in energy, because they're expanded. Not they're pushing not pushing each other away, they're just sort of drifting away, because there's no extra electrons to push anybody. So they have to be in that vacuum, but in a pretty quick time, electrons leak into there, though. It's very, very, very hard. I mean, every single thing is made out of them, so how are you going to keep them from moving around? And every single thing there is, if I take this and it's 50 degrees outside and I bring it inside and it's 80 degrees inside, this will start to absorb electrons from the 80-degree gases. If this was 80 degrees outside and I come in and it's 50 degrees inside, this is going to bleed its extra electrons into the gases that are in the air here that don't have enough. It's as simple as that. There is no other possibility. All right, and we have to get down to electron flood theory before anybody can understand anything. And they know right now, there's no question, the Bohr model does not work. Rod and I have shown the boson that they've been looking for, and we're showing light in its most basic form actually split into its particle nature. I don't think you can get much better than that. But nobody will correspond. And I've sent this to all of the top physicists. Not a single response. I don't know why nobody is either interested, or they just, I can't believe that they don't see any merit to this. I mean, nobody's that incompetent that they can just say, oh, that's not, nothing. But that's what I get every day, every single day for years and years and years. It seems like once you're stuck on a pattern of opinion, and that's all it is now in academia, it's 100% opinion. There is no stomach for honest truth. You bring something truth like I do with the Mudfossils, forget about it. They will destroy you. And I'm sure they have destroyed many that have spoken up, because I'm being mentioned in a lot of papers, like 1,700 or something papers I've been mentioned in, and a lot of them are very highly cited. They said, I think it was 140 highly cited papers. Now, those people are probably in trouble, because they are talking about reality, or else they're assaulting me in these papers. I don't know what they're talking about. But until we deal with reality. I'll be assaulted. You can assault me. I've sent some emails to the people that have cited me. I don't know what they said about me. Nobody's ever returned the email. So at this point, I don't think anybody cares about reality at all. I just really don't. I mean, the only people that care about reality are normal people that have nothing to lose by going into the realm of reality. And academia they should have embraced this. They should have said, wow, we never expected any of this. Let's look into it. And then everybody would have been happy. I'd have been thrilled. But to run up against the wall I ran up against, and still I'm against that wall, that pisses me off. That doesn't make me happy whatsoever. And everybody in my life has turned against me because they think I shouldn't be doing this, because I'm going against everybody. Well, yes, absolutely I'm going against everybody, because everybody is wrong. Chew on that for a while. All right, I love you all, but there's some of you I'm not too cuddly with, I can tell you that. Just to pay attention, let me into this. Take a look at this. Don't just whistle in the woods, especially the Mudfossils. I mean, it's getting very, very hard to accept the reality that we're forced to accept. I don't accept it at all. I don't have to accept it because I don't care about them. If you want to make a living in life, you have to accept it. Until you start speaking up for yourself, you're going to be stuck in the slave mentality. They have you forced. And that's really, it's racketeering, it's fiduciary failure, it's all of the worst that humanity has to offer exists in academia right now. Absolutely disgrace, really. And then they force you to pay them to tell you things that they should absolutely know are not true. Or especially the Mudfossils, geology and all that stuff. Absolutely, totally wrong. And I've had that evidence for years and years, presented it to Yale, Harvard, all of them. They don't care a bit. So I would go, in my world, that's fiduciary failure. I don't know if you'd call it fraud or not, but I would myself. And because it's the peer review system is set up to facilitate that type of opposition to reality, I see that as racketeering. It's the exact definition of all of those things. Fiduciary failure means they're not acting in the best interest of the students. Fraud means that they know that what they're saying is not true. And racketeering means they are putting barriers against people that want to do correct, want to do right. That's, so this is looking terrible for them, and it's time that they are exposed for this and everybody sees them as terrible. Because it's gone on too long. Velikovsky 70 years ago was put into this same box that I'm in now. And he never got out of it. But I have everything. I have all the evidence. I have every single thing that you can walk in your backyard and see it. And I have the DNA, and I have the CAT scans, and I have every single thing to back my words up. And it will never, ever, ever be turned around this time. Velikovsky, 99% of the people on the face of the planet never heard his name. He was one of the most outstanding human beings that ever consumed oxygen. This academic nonsense is over. All right? I love you all, and God bless you.